So in the last set of examples and try it exercises, we looked at what happens when something is added or subtracted to x, or in other words, a horizontal shift. In this set of problems, we're looking at what happens when we add or subtract something to the entire function. So in this case, we're given f of x equals 3 to the x and g of x equals 3 to the x plus 2. So we're going to be looking at what happens when we add 2 to f of x equals 3 to the x. So we'll start with same thing as before. X value is -2 to 2. What's x, or what's f of x? What's x f of x? What's the points for f of x? And then the same thing with g of x. So if we're looking at f of x equals 3 to the x at -2, and again, if you need to write these out, please do. I'm just, for space, not writing out finding the value of each function at the specific x value. So f of -2 equals 3 to the -2, which is 1/9. And that's going to give us the points, or that's going to give us the point -2, 1/9. -1, f of -1 is 3 to the -1, which is going to be 1/3, which gives us the point -1, 1/3. At 0, f of 0 is 3 to the 0, which is just 1. So that's going to give us the point 0, 1. At 1, we have 3 to the 1, which is going to be 3. So that gives us the point 1, 3. And at 2, we have 3 squared. F of 2 equals 3 to the 2, which is going to be 9, which gives us the point 2, 9. So we'll go ahead and graph f of x. So we have the point -2, 1/9. -1, 1/3. 0, 1. 1, 3. And 2, 9. Which gives us this curve. Typical fashion with no shifts, passes through the point 0, 1 for our y-intercept in the negative direction. We have x approaches the x-axis, and in the positive direction, it goes to infinity. Now, what happens when we add 2 to the entire function? Well, we could go through the process of 3 to the -1, or 3 to the -2 plus 2, 3 to the -1 plus 2. But we already have what 3 to each value of x is. That's what f of x is. So we just add 2 to the values for f of x. So g of -2, again, that's going to be 3 to the -2 plus 2. Well, that's going to be 1/9 plus 2. Well, what's 1/9 plus 2? That's 1/9 plus 18/9, which is going to be 19/9. So our point is going to be -2, 19/9, which is 2 and 1/9. At -1, g of -1 is going to be 3 to the -1 plus 2. Well, that's just going to be 1/3 plus 2, which is 2 and 1/3, or 7/3. So essentially, we're just adding 2 to each one of the f of x values. So g of 0 is going to be 3. G of 1 is going to be 3 plus 2, which is going to be 5. G of 2 is going to be 9 plus 2, which is going to be 11. So this gives us the points -1, 7/3, 0, 3, 1, 5, and 2, 11. And again, if you need to write these out, go ahead and write them out. So for instance, let's say we're looking at g of 2. Well, g of 2 equals 3 to the 2 plus 2, which equals 9 plus 2, which equals 11. And again, that's what I'm doing. I'm just not writing it down. If you need to write it down, please go ahead and write it down. So let's go ahead and graph that in a different color to differentiate. We have the point -2, 19/9. And again, remember, that's 2 and 1/9. It's just 2 more than what f of x is. So at -2, we have 2 and 1/9. At -1, we have 2 and 1/3. At 0, we have 3. At 1, we have 5. And at 2, we have 11. All right, and then we connect those dots. So as you can see, what happened to the graph of f of x when we added 2 to the entire function? It just shifted everything up 2 units. So remember, with horizontal shifts, it's going to be what's being added or subtracted to x. If it's being subtracted, we move that many units to the right. If it's being added, we move that many units to the left. When something's being added or subtracted to the entire function, it shifts it vertically up or down, but in the same direction as the sign. In this case, we were adding 2 to f of x. G of x equals 3 to the x plus 2. So everything shifted up 2 units.